So when you consider the carbon occurrence, carbon can be present in the combined form, and we'll discuss the compounds of carbon. If the carbon is combining with hydrogen and oxygen, then they are said to be the organic compounds. Whereas the other combinations of carbon is said to be inorganic compounds. So basically you can classify the compounds into two, organic and inorganic. So here carbon combines with hydrogen and oxygen. So just like in case of CH4 you have methane, or when you consider C6, H12, O6 you have glucose. So all these are examples for organic compounds. Whereas when you consider the carbon monoxide, carbon dioxide, these comes under the category of inorganic compounds. So we'll focus on the organic compounds where carbon and hydrogen combines to get the hydrocarbons. And hence, you have the common category called hydrocarbons. So hydrocarbons are the organic compounds and they are formed by the combinations of carbon and hydrogen elements. These hydrocarbons can be again two types: saturated hydrocarbon and unsaturated hydrocarbon. So they can be saturated or unsaturated. In saturated hydrocarbons, the valency of carbon, as you know, valency is the number of electrons shared or the number of their combining capacity, the number of hydrogens that they are combining. So in saturated hydrocarbons, all the valencies of carbon is satisfied by the hydrogen, or you have only CH bonds. The valencies are satisfied by the hydrogen. Whereas in unsaturated compounds, there is either a presence of double or triple bonds. So let's see the saturated hydrocarbons. So this stands for hydrocarbons. In the saturated hydrocarbons, they are generally known as alkanes, and their general formula is written as CnH2n+2. So let's consider the example. Let's consider where n is the integer. If n is equal to 1, then you have the first type, CH4, and this is called as methane. So how you are going to name the alkane? For the naming of any organic or inorganic compound, you have a union called International Union of Pure and Applied Chemistry, and this is called IUPAC or IUPAC. So we are following the IUPAC naming system, and according to them, they have suggested a set of rules to name the organic compounds. In naming of alkanes, you have two words, prefix and a suffix. So prefix will be the name alk, and the suffix, the word ends with ane. So the prefix depends on the number of carbons present in the system. As we have already discussed in our previous videos, carbon has the catenation property. They are able to link and they can form varieties of hydrocarbons. So if the system has only one carbon, so let's consider number of carbons and the prefix given for them. If the hydrocarbon system contains only one carbon, then meth is the prefix given. If it is 2, you have eth, then you have prop. If it is 4, you have but. For 5, you have pent. If the carbon, total number of carbon present is 6, then you have hex. 7, hept. For 8, oct is the prefix used. If it is 9, you have non. And for 10 carbon system, the prefix used by IUPAC is dec. So this is the prefix used to name the alkane. Let's consider if you have the alkane C2H6. So let's consider C2H6. So when you analyze the system, you are able to link CC bond, their catenation property. So write down the skeleton first. Once you draw the skeleton, now satisfy the remaining valencies by hydrogen, then only you are able to get the alkane. So for this system, 3 bonds are remaining as each carbon has 4 bonds. So one is already bonded with the next carbon. So the remaining valencies are satisfied by the hydrogen. So that indicate you have C2H6. So CnH2n plus 2 is the formula for the alkane, and for this system, as you have 2 carbon, this is eth followed by ane, and hence you have the name ethane. So similarly, we can do the naming of hydrocarbons for alkanes according to the IUPAC rule, and we have several sets of rules to name unsaturated hydrocarbons also.